Okay, I forgot my setup today. Like I thought it was here in my office, my tripod, my little thingy. It's all at home, so I'm gonna have to sit down like this and lecture today. So, oh well. We stopped last class. We had this really interesting problem with the mixture, and it caused a lot of confusion. Remember this? We switched it from a chemistry problem to a sweet tea problem. Remember? Yeah? Okay, let's try and just read through it because I do want to finish this problem out. We had said that we had basically two containers, and we said they were tea. And one of them had 20% sugar in it. The other one had 35% sugar in it. We wanted to mix them together to get 15 ounces of 30% sugar. So how much of each do we mix in there? And what we did is we determined towards the end of class, we said, okay, let's let X be the number of ounces of A, and A is the 20% sweet tea. We said let Y be equal to the ounces of the 35% sweet tea. And we knew that when we add the X, that's how many ounces, with the Y, we should have a total of 15. What does this represent? I mean, the X plus the Y equals 15. 15 is coming from what? From what part of this up here? The 15 ounces, right? We need 15 ounces. So however much of X you put in there, let's say it's 10 ounces, right? Then you would put how many ounces of Y? 5. If you put 9 ounces of X, you now have 6 ounces of Y. Together, they have to add up to be 15. But we don't know how much of each. Okay? Now, the next part is to use somehow this 30% that we want at the end. We want our final mixture to have 30% in it, right? So the way that we do this, all right, and I'm trying to kind of guide you through this, is I'm going to start a new page. Remember, X is the number ounces of A. Y is equal to the number of ounces of B. So the question is, let's say that I pour in 10 ounces, or let's say 100 ounces. All right, let's just say I did that, of X. How much sugar would be in there? Remember, the A here had what concentration of sugar? It was 20%, right? What was the B mixture? 35? Okay, so again, if I put 100 ounces of A, how many of those ounces would be sugar? What's 20% of 100? 20, right? Percent means out of 100. So if I pour 100 ounces of A, 20 of those ounces should be sugar. If I pour 100 ounces of B, how many ounces would be sugar? 35. You'll follow that? All you're doing is taking, as the example, 100 ounces of A, and you're multiplying it times 0.20. Isn't 0.20 20%? If you multiply it out on your calculator, you get 20. Same thing with over here. If I do 100 ounces times 0.35, that gives me 35. Do you follow that? What if I pour 50 ounces of A? How many ounces of it would be sugar? Instead of 100 ounces, I do 50. Well, you take 50 and you multiply it by what? 0.2 again, and you would get 10. What if I poured, let's say, 10 ounces of the 20% mixture? How many ounces of that would be sugar? 0.2. 0.2 times 10, which is 2. Look, what I'm trying to get at is there's a pattern here. However many ounces you're pouring in times 0.2 is how many ounces of sugar you're going to have, right? However many ounces you pour in times 0.2 is how many ounces of sugar you're going to have. However many ounces you pour in times 0.2 is how many ounces of sugar you're going to have. So how many ounces of A are we going to pour in? We don't know, do we? So what have we called it? X, right? X. So couldn't we say X times 0.2 is how much sugar we're going to have? And isn't that just 0.2x? Yes? Okay. Now what about the Y mixture over here? This one. How much of that are we going to pour in? How much, sorry, of the B? How much of that are we going to pour in? Well, that's the concentration of it. How much are we going to pour in of the B? Do we know? No. So what do we call it? Y. So we take Y and multiply it by what? 0.35, and you get 0.35Y. Do you kind of see that? All you're doing is taking how much you're pouring in and multiplying it times the percentage. Now, what do we know about these two concentrations added together? What does it have to give me? What's the concentration of sugar in the final product that I want? 30%, right? 30%. So watch the way I'm going to write this down. I put 0.2x plus the 0.35y equals, so 0.2x is how much sugar we have from pouring in A. 0.35y is how much sugar we have from pouring in B. And that should equal our final mixture, which is 0.3, right, times how many ounces in our final mixture? Do we know how many ounces are in the final mixture? 15, right? So shouldn't this be 15 times 0.3? See, every one of these, I'm trying to get you to see that every one of these pieces here is your concentration times how much there is, plus the concentration times how much there is. That should equal the concentration times how much there is. So doesn't this give us another equation? I still have to do 0.1. I still have to do 15 times 0.3. What's 15 times 0.3? What is it? 4.5. So I have 0.2x plus 0.35y equals 4.5. That's my second equation. And that's what I needed, right? A second equation? So as I go back and I put that together with the first equation, I'm going to write my system on a new page. Okay, the first equation we had was that when we add the two together, I have to have 15 ounces. And now I just got 0.2x plus 0.35y must equal 4.5. And we get to choose how we want to solve this. So any questions or any recommendations, suggestions here, what we should do? What's that? You want, okay, yeah, let's get rid of the decimals first. That sounds good. So let's look at this. How many places should I move the decimal in each one of those three terms in that second equation? 2 places for every single one of them, because the 0.35 needs 2 places, so all of them have to go 2. So this system is going to turn into what instead of 0.2x, it's going to be what? 20x plus 35y equals 450. Questions on that? Okay, now you have choices in how you want to solve this. I think I'm going to do the addition method or elimination method, which was the second one that we've looked at. I'm going to try and get my x's to go away. So to get these x's to go away, I need to put a negative 20 in front of that x, right? So I'm going to multiply the first equation by negative 20. And let me rewrite that entire thing over here. I should get negative 20x minus 20y equals negative what? 300. And then I still have 20x plus 35y equals 450. I'm sorry to do this to you on a Monday morning, but we had to finish this off, okay? What do I do after I get these x's to be opposite like this? Just add straight down, right? We should get 15y equals what? 150. Now divide both sides by what? By 15, and we get y is 10. Once you know what y is, you can go back and get x, can't you? Where do you plug this y into? Any equation I want. And I think the first equation way up at the top was probably the cleanest, easiest ones. Or you could just think about it. We're pouring in 10 ounces of y, aren't we? Isn't that what that says? So x has got to be what? Remember how much total did we have? 15? So x has got to be 5. But you could still get that by taking it and plugging it in right here. So x plus y, we said, is going to be 10. So x plus 10 equals 15. Subtract 10 on both sides, x is 5. So if you are sitting there and you have sweet tea that had 20% sugar in it, and you had another pitcher of sweet tea that had 35% sugar in it, and you wanted to pour yourself a 15-ounce glass of tea that had 30% sugar in it, you would pour 5 ounces of the 20%, you would pour 10 ounces of the 35%, stir it up, and you'd have exactly 15 ounces of 30% sugar. Now, of course, you're never going to do that, right? But like I said, this is more applicable to a chemistry class where you start out with some stuff in the lab back in the storage room. It's pre-mixed at certain percentages. For your experiment, you need a certain number of ounces of a certain concentration. So you mix, you run out a system of equations like this. You figure out how much of each to pour. You pour it and mix it up. That's what you use for your experiment, okay? All right. We're done with this section. I bet you're happy about that. Would you like me to work another one of these like really quick? I mean, now that we kind of have the framework of it, do you want to see one worked out real fast, at least to set up the equation? Because I think that's the hardest part of this. I do plan on giving you one of these on the test. So, which is when? A week from this Wednesday. So next, is that right? Next Wednesday? Come on, let me turn this over here. We have, yes, a week from this Wednesday. So next Wednesday you have your exam 3. Okay? All right. Did I give you number 20? Sorry, 21 out of the book on page, out of your homework, or did I stop? I stopped you at 15, didn't I? Okay. If you have your book, or if someone at your table has a book, I'll write it down just in case you don't. I'm going to do number 23, all right? It says, how much 45% disinfectant solution must be mixed with a 30% disinfectant solution to produce 20 gallons of a 39% disinfectant solution. Question. This is exactly the same as the sweet tea problem, okay? But instead of having a 20% sweet tea and a 35% sweet tea, we have what? Instead of the 20 and 35, what do we have? 45 and 30, right? We're going to mix those together to create how much? 39 is the percent, but how much of it do we want? 20 gallons, right? Of 39%. So we're going to call X and Y, right? We're going to determine what our X and Y are here. Let's let X be equal to the number of what? What was it in the previous problem? It was the number of what? Ounces of the sweet tea that was 20%. Here, what does it look like they're measuring our volume in? How much there is? Gallons. Do y'all see that in the problem? Right? Gallons. So we're going to let X be equal to the number of gallons of the 45% mixture, or 45%. I'm just going to put dis for disinfectant. Do y'all see that? Any questions on that? What would Y be then? Okay, so but still same thing, number of gallons of it? Okay, the number of gallons of the 30% disinfectant. From that right there, just those two things, we can set up our first equation. It would be what? X plus Y must be 20, right? Because you have the number of gallons of the first one, the number of gallons of the second one that you're going to pour in. There's the first equation. Now the next equation comes from their concentrations. So let's see if we can do it without thinking too much about it. The first part of the equation comes from the 45%, right? And that 45% goes with which variable? X. So I'm going to write, instead of 45, I have to turn it to a decimal, and I put what? 0.45 what? X, okay? So the next equation will become the 0.45x plus the next part of the equation comes from the 30%. 30% goes with what variable? The y. So 0.30y. Is that all right? Now that must equal, and this is a critical step. Don't miss this little subtlety here. The right side of that equation should be what times what? Good. It's the 20. Don't forget that 20. The 20 times the 0.39. So I put 20 times 0.39. And I'll just draw a little arrow here. This is the concentration times the amount. And in this case, in gallons. Every one of these mixture problems is going to turn out that way. Your first equation is always going to be how much of each. The second equation is always going to be the concentration times how much of it you have, plus the concentration times how much of it you have equals the concentration times how much you have at the end. Okay? Now, I'm not going to solve this, but you could take this the rest of the way, right? Doing what we just did. I will tell you what the answers. You should, if you work this out on your own at home, you should get 12 for X, and for Y, you should get 8. So that means you would pour in 12 gallons of the 45%. You would pour in 8 gallons of the 30%, stirred up. You would have 20 gallons of 39% mixture. Does that help a little bit to see another one work through without all that crap added on? Yes? Okay. All right. So your homework, the last one out of this, is page 312. Try number 21, whoa, 21 and 25. Now, I'll tell you something. On 21, just ignore the table. They give you a table to fill out in 21. Just forget it, all right? Just do it like I did in class, all right? And we're done with this section. So there are 3 types of applications that we did. We did a cost application. We did an interest, like interest. And then we did mixtures. That's what we covered. So any one of those could appear on a test. You could have more than one of those on a test, but I'm guaranteeing you a mixture problem on the test. All right, we're going to move on to 4-5. No, hold on a second. I'm jumping the gun here. We actually are going to skip, not 4-5. We're going to do 4-5. You'll do 4-5 in a college algebra class. We're going to 9-5. So this is kind of weird. We're going to skip several chapters in the book and go all the way to 9-5. It seems like it doesn't make sense to do that, but you'll see when we get there, it's very much connected to what we've been doing. So this is going to be called linear. That's good. We've seen that before, right? Inequalities. And systems of linear inequalities. And I'm going to put in here in 2 variables. All right. I can't stand sitting down. All right, linear, let's talk about this. This is 2 separate ideas. We have linear inequalities, that's one idea. We have systems of linear inequalities, that's another idea. Both of these involve 2 variables. So let's see what in this we are already familiar with. If this said linear equations, right? Equations in 2 variables, what's a linear equation in 2 variables look like? What's a linear equation in 2 variables? X plus y equals 10, let's say, right? That's a linear equation in 2 variables. And if I were to ask you what this is geometrically, what is that? Go back to the idea of, well, I don't know. I want you to tell me. Geometrically, what is this? Picture-wise, what is this? Think about it. It's a linear it's a line, right? This is a line. If I graph it, it's a line. How would you graph that? There were 2 methods we learned to graph a line. You could do, that's the intercept form. That's where you set one of them to 0, you solve for the other one. Set the other one to 0, solve for the other one. That's called the intercept method. The other method was to get y by itself, and then use the fact that if you get y by itself, you can make it look like this, y equals mx plus b, right? Yes? So we know that a linear equation in 2 variables, equation, is a line. What is a linear inequality in 2 variables? So what the hell is an inequality? We have to talk about that first, right? What's an inequality? Inequalities look like this. There are 4 of them. This, 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 and this. Y'all seen those before? Okay. So here's the definition of those. If I say x and then I put this symbol here, what does that mean? X is greater than y, right? This means then x, if I draw it on a number line, right, here's a number line. This means that x is over here somewhere and y is over here somewhere. Do you agree? On a number line? X greater means you're to the right on the number line. Now what if I write this? If x is less than, right, y, that means x is smaller than y. So on the number line it would look like this. Just flop them around right there. Now below these, I'm going to put how you say it, x greater, I forgot to put it up there, than y. Here, x less than y. Now how do those two symbols differ from these? What if I write this? How is this different than the one up here? Yeah, it's an or statement, right? It's like oh, it's saying two different things. It's saying either x is bigger than y or they are the same. So I'll give you an example. It's harder to do on a number line, but I'll give you some examples. Is this true? Is 4 greater than or equal to 3? Is that true or false? That's true? 4 is bigger than 3, right? Is 4 greater than or equal to 4? Yes. 4 is not bigger than 4, but 4 is equal to 4. So that's true, right? Is this true? 4 greater than or equal to -5? Yes, because on a number line, where's -5? Over here? Where's 4? Somewhere over here? 4 is actually to the right of -5. So that's true also. We have to just be a little careful with negative numbers. Where are they positioned? How about this? -7 greater than or equal to -8. True or false? True. True. Because you have to look at the number line. -7, well, here's 0, right? -7 is here. -8 is next to it, isn't it? So when you're on the number line, as you count negative, you go to the left. So -7 is to the right of -8, so it is bigger. So that's true also. Okay. So this symbol right here, I'm going to write it underneath, is saying x is greater than y or x equals y. It can be either one, and it's true. And then, of course, if I flip it around and do the last symbol, this says that what? How is x related to y here with this last one? X is less than or equal to y. All right, I'm expecting that everyone has seen inequalities before and have seen the symbols and mess with them a little bit. So this is just kind of refreshing your brain a bit. So now let's go and get into what today is about. Here's your first example. I would like for us to look at this problem right here. 2x minus 5y equals 20. Sorry, not equals. We're doing inequalities. Greater than or equal to 20. Now, graphically speaking, if that was an equal sign, just an equals, it would be a line, wouldn't it? It'd be a line. But it's not an equal sign, it's an inequality. So how does this change what we learned already? Well, let me show you how this changes things. Can anybody right now give me an x and a y that make this true? Any x, any y that makes this statement true? How about if x is 10 and y is 0? Does that work? What if x is 10? What do you get? 20. What if y is 0? 0. Is 20 greater than or equal to 20? Yes, so that would work. Agreed? Now, would this work? 11, 0. That would still work because 2 times 11 is 22. Is 22 bigger than 20? Yes, so that would work also. How about this? How about 12, 0? That would work. And I could keep going, couldn't I? Now, look at this right here. These points, 10, 0, 11, 0, 12, 0, if I were to plot those on a number or on a plane like this, like we do with graphing lines, 12, 0 would be out here, wouldn't it? 10, 0 would be, or 10, 11, 0 would be next to it. Do you all agree with that? So this over here was a line, right, with the equals? And when we did that, we had one x-intercept and one y-intercept, didn't we? What do you see here? Look at this. I'm giving this example right now. It looks like we have 3 x-intercepts, don't we? Can this possibly be a line like it was before? Doesn't seem like it is. It's something, but it's not a line. Let's see. Maybe we can get y-intercepts. How do we get y-intercepts for something like this? How do you get a y-intercept for over here? To find y-intercepts, you set what to 0? X to 0. Can you set x to 0 here? Okay, imagine it's not there. How can someone give me a y that would make this true? -4. Good. Would 0, -4 make that thing true? So 0 makes the x term go away. -5 times -4 is what? 20. 20 is greater than or equal to 20. Agreed? Okay, that would work. What else? -5. Let's see. 0, -5. If I do that, -5 times -5 is positive 25. That's bigger than 20. So that would work. I already have more than one y-intercept, don't I? Let me put them on our number line here. Let's just say this is like -5 there. I would have it here, and I would have it here. Do you all see that? So I have more than one y-intercept. So what the hell does this thing look like, right? It's kind of weird looking, right? Here's what we're going to have, okay? We're going to have, instead of a line like we did before, we're going to have an entire region of the plane. In other words, region meaning like a shaded area instead of just a line. It'll turn out for this problem, it'll be exactly, let me see, 10, and then, say -4. It'll be, that's supposed to be a straight line, sorry. It'll actually turn out to be everything down here. Every point that I've shaded will work. In other words, we'll make that inequality true. You can kind of see it here. On this line, this point worked, and then this one works. And if I kept on going, -6, -7, any of those would have worked. And then over here, I could have gone 10, 11, 12, and I could have kept on going. But it turns out that anything in here would have worked also. But let's try something like this. What about the origin? Would that have made that true? Plug in 0, 0. You get 0 is bigger than 20. That won't work, right? So we're going to have a formal way of doing this, all right? I'm just trying to show you that a linear inequality in 2 variables is not a line. It is going to turn out to be an entire shaded region of the plane. Okay, so how do we actually do this? How do we actually go about figuring it out? Okay. All right, my two sleepy guys over there. Guys, y'all look real comfy. I'll give you an opportunity right now to tell me what the linear inequality in two variables, what the answer should look like. You don't need to write anything down. I just said what it was. Any idea? Anybody else know what the solution to a linear inequality in two variables looks like? Shaded region of the plane. Okay, when you're asleep, you get no information here. So if you're going to sleep, just leave. All right? Or stay awake, one or the other. All right, we have 2x minus 5y. I'm glad someone said shaded region of the plane, because then I would have been like, well, I guess it doesn't matter if you're awake or asleep in here. All right, so here's the standard step for this. We first have to, we have to make sure we understand it's a linear inequality, all right? And it doesn't matter what inequality symbol you see. If it's this one, this one, this one, or this one, any of those four, okay? In all cases, we will do them all the same. The first step is turn it into an equation. All right? I'm going to turn it into an equation. So let's do that. 2x minus 5y equals 20. The second step is to use the intercept method or the y equals mx plus b, which we call the slope intercept method, to graph the, what is that going to graph to be? This linear equation in two variables, what is that graph to be? A line. So I want to use the intercept method or the y equals mx plus to graph the line. Okay? Now there's a huge kicker here, all right? There's a huge thing we have to be careful about. I'm going to put it right under this. Careful. If, okay, if you have this symbol or this symbol in your original problem, that equal sign tells you something about your line you're going to draw. Okay, so if you have one of those two inequalities in the original problem, draw a solid line. If you have one of the other two in original, any ideas what you'll do? A dotted line. Draw a dotted or dashed, however you want to call it, whatever you want to call it, line. Now, why do you think that is, that you would draw a dotted line or a dashed line? I'm going to do it on the board here so you can kind of see why. Do you remember this? The difference between x being bigger than 4 and x being bigger than or equal to 4? These are inequalities with one variable. X being bigger than 4 on the number line meant here's 4. That means I could be anything to the right of 4 and 4 itself, and we put a solid dot there or a bracket. Do you remember doing something like this? And this one up here meant that you could be 4, anything to the right of 4, but could you be 4? No, because there's not an equal under here. So you would put either an open circle here or that parenthesis. Do you all recall that? It was interval notation. Well, that's what you do if you have an inequality with one variable. With two variables, we have lines. And so the question is, do you want to include that line or you do not include that line? To include the line, we draw it solid to let you know every point on that line is part of our answer. If we don't want to include the line, which means we have something like this, inequality, how do I say I don't want to include every point on the line? My best way is to draw it dashed. That's the best I can do. Kind of see the difference between the two? So it just tells you how to handle that boundary line. All right, so that's the second step. Draw the line either dashed or solid. Third step, I think I'll start a new page here. Third step is to shade one side of the line. What do you think the question you should be asking yourself is, though? Which side, right? Which side? To determine which side my thing is acting weird. Flip a coin. You think that? No, it can't be that, right? No, it's not that. There's actually a way to figure it out. You don't flip a coin. You don't just say, it looks like it might be the top. What you do is this. Do you remember on the previous problem that I had where I said, hey, take a look at the origin right there, 0, 0. Did that work? No. That told me that that point didn't work. And guess what? Every other point on that side of the line won't work. Pick anything. How about this one right here? How about 0, 5? Would that work? 0, 5. If I put 0 here and 5 in there, I get negative 20. It's not going to work. So it's not just coincidence. With linear inequalities in two variables, it's one or the other. So if one point on one side doesn't work, then we can throw that side out completely. If it does work, what? What if I plugged in 0 and 0 and it did work? That would be the side I shade. Yes. I did. Well, I haven't gotten to it. Technically, I haven't forgotten until the end of class, but you're reminding me, so you get, what's your last name again? I don't know. We'll have to, just after class or something, we'll work on it. No, I want to give you something for it. The reason I don't know is because I tore off last time. This is brand new. So if I wrote something down on it, I wouldn't know right now. Okay. All right, so let me get to where we are. We're going to shade one side of the line. To determine which side, what we're going to do is pick any point we want, as long as it's not on the line. Now, I picked 0, 0 a while back, right? When I was showing you that example a second ago. 0, 0 is always a good point to pick, if you can. But sometimes your line goes through 0, 0, so you can't pick it. All right? So pick any point as long as it doesn't go, as long as your line doesn't go through it. And then what do I do with that point? See if it works. But what do you mean? See if it works where? What? Not the equation. The original inequality. So you have to go all the way back to the beginning of the problem and plug it into the original problem. So pick any point, plug it into original problem. That's the one with the inequality in it. And then what is that going to tell you? If it works, what do? If that point works in the original problem, if it makes a true statement, then what do? Shade that side of the line, right? If it doesn't work, shade the other. So I'm just going to write that out, okay? So I'm going to determine which side of the line, I pick any point, I plug it into the original problem, right? If it works, shade that side. If it doesn't, shade other side. And that's it. Those are the steps. Just make sure that you do not pick a number on the line, okay? So just when you're looking at your picture, you make sure that you just kind of stay away from the line. If there's any doubt, like, is that too close? Just go pick something else. The answers to these problems, okay, on a test, your answer is going to be a shaded region of the plane. I mean, there's no answer like x is 2 or anything like that. The answer is a picture of a shaded region of the plane. Now, some people at this point like to break out graph paper. Some people like to use colored pencils. It's all about you and how artsy you are and how into that you are. You can do it with just a pencil and a piece of paper. You don't need anything fancy. But if you want to, you can. All right, here we go. We're going to do an example. Let's solve this inequality. Negative 5x plus 2y less than 6. So you look at this, and this is where, again, I've been trying to give you this foundation of language a little bit in this class. You are looking at here an inequality, not an equation, right? This is an inequality, and it's linear because your x's and y's are not raised to any powers. So it's a linear inequality, and how many variables do you have? 2, okay? These are linear inequalities in 2 variables. These are linear inequalities in 1 variable over here. We know how to do those. Now we're going to work on these. So the standard steps for solving a linear inequality in 2 variables is, step 1, making an equation. Now, after I do that, what do? Or y equals mx plus b to graph this as a line, right? So which method do you like here? Do you want to do the intercept method? That's where you set one to 0 and then solve for the other, then do the same but backwards? Or do you want to do y equals mx plus b? It's up to you, really. I mean, it really doesn't matter. It's up to you. But in this one, I made it so it would work out better as y equals mx plus b. Because right now, if I set y to 0, right? If I set y to 0 and I solve for x, I'd have to divide -5, and that's going to give me a decimal, right? So let me try. I'm going to choose to turn this into y equals mx plus b. That's what I'm going for. So I'm going to move the -5x to the other side, which makes it a positive 5x. Right? All I did was add -5x on the left. I added 5x on both sides. Now what? Divide by 2 on everything, right? So it becomes 5 over 2x plus, what's 6 divided by 2? 3. Does everyone see I have y equals mx plus b? Yes? Remember, m here for us is 5 over 2. B is 3. How do I graph that now? I draw a graph, right? X and Y axes. Where do I start my graph? At 3 where? on the y-axis. So you start with the y-intercept 3. What happens if you accidentally, instead of going on the y-axis to 3, you go to the x-axis on 3? Like, what if I went down here to the 3 on the bottom there? What if I did that instead? It's wrong. Okay? It's wrong. You can't make that mistake on a test. You've got to know that B is the y-intercept, not the x-intercept. So there's my y-intercept. Now, how do I get to another point on this graph? I use my slope, right? Rise over run. So up 5, to the right 2. Up 5. 1, 2, 3, 4, 5, to the right 2. And here. And then I do what? Draw a line. Now, just any line, we have to now pay attention to the original problem. The original problem was an inequality sign that did not have the little equal under it, right? So because of this right here, that tells me, and I would have known this right when I looked at the problem to start with, that it's a dashed line. Dashed or dotted, however you want to look at it. It's going to be a dashed line. So I come back down here and I dash this thing. I don't even know if I have the ability to dash this. Well, I don't. Oh well. Goodbye. Okay? Are we done? No. Next thing is to pick a point, as long as it doesn't lie on the line, and basically plug it into the original problem and see if it comes out to be true or false. So what is a really good point that I know does not live on that line? 0, 0. Here's the 0, 0 right there. We call this 0, 0 a test point. Why? Well, I'm about to test it into the original inequality, see if it comes out to be true or false. So let's go back up to the original problem up there. Okay, it's negative 5x plus 2y was less than 6. I'm plugging 0, 0 into it. Doesn't that turn the whole left side into 0? And I get 0 is less than 6. Is that true? Yes. We're done. I mean, we have to shade, but that's it. That tells us right there which side. So because it's true, because it did work, that means everything on that side works. So I'm going to shade everything on that side of the line. So my final answer is just everything on this side of the line. You don't have to go all the way up to whoa, come back here. I mean, this is good enough. I know it's that line. I know it's everything to that side. Okay? Now let me show you something. I'm going to bring a new page up here. Just want to show you how having a graph paper is probably, if you have it, if you can bring it, if you're not very neat and you want to become neater, how the graph paper can really make your picture look a lot better. Here's 3. I want it 1, 2, 3, 4, 5 to the right 2. I drew a dashed line, right? So you break out your ruler. Right. Break out your charcoal pencil to shade. No, I'm just kidding. You just, do this, and you're done. All right, it looks a little better, whatever. But here's the reason why I encourage you to do graph paper. Because what was the title of this section? Oh, I went too far. There we go. It was linear inequalities, which is what I just did, right? A linear inequality means we're going to shade part of the plane, doesn't it? But then the next thing we're going to look at is systems of linear inequalities. Systems meant we had two of them, right? So you're going to have one shaded part of the plane mixed with another shaded part of the plane, and the total answer is where those two shaded parts overlap each other. So if you get real scrappy with your drawings, this second part of this section might become difficult. So next class, make sure if you think graph paper will help you be organized or make your stuff look better, then bring it. Okay? So I'm actually going to do one more example of this, and let's see what time it is when we're done. I don't think I'm going to start the linear inequality systems today. All right, how about this? Example. Solve this. 4y is greater than or equal to 3x. This one is tricky because it's almost too not simple, but it looks too simple that it's confusing. First thing I notice, I have an inequality, right? I have two variables, it's linear. So it's a linear inequality in two variables. So this is exactly what we've been doing so far. The first step is to take this and turn it into what? An equation. 4y equals 3x. Now that's a line, right? How do I graph that line? How do you want to graph that line? Do you want to find the x and y intercepts, or do you want to do y equals mx plus b? You want to do x and y intercepts? If we want y equals mx plus b, right, all we have to do is divide by 4, don't we? If I go for the y equals mx plus b, all I have to do is take this thing and divide by 4 on both sides, which would give me 3/4 x, wouldn't it? So what is m here? No, that's b, right? M is the 3/4. But b is out here, and you don't have a b, so what's b? 0. Okay, if b's not there, it's a 0. Does everybody follow that? Okay, now let me just warn you, if you had tried to do the intercepts, to find the x-intercept, what do? You set y to 0, right? So you would have got 0 equals 3x, which would have told you x was 0. If you try and find the y-intercept, you would have put 0 here, and you would have got 4y equals 0, and that would have told you y was 0. So in both cases, you would have got 0, 0, which is just the origin. That's not enough to be able to draw a line, because it's just one point. The x and y intercept is the same here. So the moral of my little going off on tangent here is to say, if you tried intercept method there, it wouldn't work. This would work, though. Okay, you ready for me to draw? I'm about to draw a solid or dashed line. Solid line. It's going to start at a y-intercept of what? It's my third step. It's going to be a y-intercept of 0, and then to get to another point, I do what? Rise 3 to the right 4 here. Then I draw a solid line through those. I missed them both. It was hard to do, to miss them both. I was going for that. I was trying to miss them both just barely, and I did it perfectly. Look at that. Now what? Pick a point. Pick a point. So how about I pick, well, what would you pick? Can't pick 0, 0, can you? 1, 1? Are you sure 1, 1 doesn't live on that line? 1, 1 is too close for me. I agree it doesn't live there, but I think it's way too close to pick. 1, 2? What do y'all think? 1, 2? I think 1, 2 is far enough away. You could pick 1, 2. I'm going to pick something else, though. I'm going to let one of my variables be 0, because I know it'll kill that variable off, won't it? So why don't I pick something like this? 1, 2, 3. How about I pick the point 4, 0? Now that's real far away, right? And one of my variables is 0, so it'll kill it off. Let's plug that into the original problem. If you wanted to pick 1, 2, you can, and I encourage you, try it for yourself, or I can do it myself after this, and we'll show that one of these is going to work, the other one's not. 4, 0, the original problem was 4y is greater than or equal to 3x. So I'm plugging in what for what here? If I plug in 4, 0, the y is what? 0, so I get 4 times 0. Is that bigger than 3 times what's x? 4. Is 0 bigger than or equal to 12? Not today. So that point does not work, which means everything on the other side of the line should. So I shade the other side. Y'all see that? Now just for demonstration purposes, I'm going to plug in, what did you say, 1, 2? Okay, if I plug in 1, 2 instead, it should work. So I go 4 times, now 2 was y, greater than or equal to 3 times 1. You get 8 is greater than or equal to 3. That's true, so it works. So you would have shaded everything on that side of the line, which is the same conclusion I got from doing it the way I did it. Is that all right, everyone? On step 1, yes, you put equal. Oh, wait. You mean to do this third step where I'm testing? Remember, when you test that point, where do you test it? Plug it into original problem, okay? That means the very beginning, not your step 1, but the original problem. Excuse me? Yeah, we use, the only reason we use equal is so we can graph the line. After that, we're wondering what the inequality is telling us, which side of the line. Does that help? What about this? This one won't take as long. These won't take as long. What about this? Solve x greater than -4. And I'm telling you this is a linear inequality, 2 variables. I'm telling you this. Did that sign-in sheet get around to everyone? This can be a very confusing problem because, like this over here, look at what I put up on the board. X bigger than 4, x bigger than or equal to 4. We look at this as being part of the number line, don't we? But this right here, I'm telling you, what does x is bigger than -4 look like if you're looking at it on the plane? What the heck? That's confusing, I think, a little bit. Let me draw this for you. Where is -4 here? Where's x is -4? On the x-axis to the left a little bit. 1, 2, 3, 4. -4 is right there. Do you agree that that point right here is x is -4? Do you agree at that point x is -4? Do you agree if I go straight up that that point has an x value of -4? Yes? That any point straight up and down, any of those points has an x value of -4? So this can be looked at on the plane as opposed to on the number line. Now I've got to follow the steps the way we did before. So the first step is to turn it into an equation, right? X equals -4. And if you look back in your notes, x equals -4 is a vertical line. Go back when we first started talking about lines. X equals a number is a vertical line. So the second step is to use x-intercepts or y-intercepts, or x and y-intercepts, or y equals mx plus b. But I already know what this looks like, right? It's a vertical line. The question is, it's solid or dotted? It's dotted. So I'm going to skip part 2. The reason I'm skipping part 2 is because I know it's a vertical line. So my step 3, when I draw it, I go to -4. I draw a vertical line here, and it's dotted. Test point, anyone? 0, 0. Plug in 0 up into the original problem. The original being way up here. Plug in 0, 0 into that. Well, really, all you're doing is plugging in x is 0, right? So is 0 greater than -4? Yes. 0 is to the right of -4, isn't it? 0 is to the right of -4. So that is true. 0 greater than -4, that is true. And therefore, I shade everything on this side. I'm going to let you go, but what if that had said y is greater than -4? It would have been a horizontal line instead of a vertical line. All right, let me give you your homework. For homework, page 675. Man, there's so many good problems here. How about 17 through 27? Odd. They don't have any vertical and horizontal ones here. Oh yeah, here we go. Let's then do 33 through 39 odd. Have a good day, everyone.